Thank you, Devdatta. Uh, Good morning, all. Thank you for having me here. I'm Nilay Nishant, working at Northeastern Space Application Center. We are based out of Shillong. Uh, this talk is basically on the general insights of what are the applications that we have developed for the Northeastern regions, government and user departments, and how they are being utilized. All these applications, whichever I showcase, are developed on open source technologies. So to start off with, what are the basic pillars of smart governance? Now, if we talk about smart governance, it's basically developing data, digital platforms, and collaborative process that make all the public processes easier. Data-driven decision-making is one of the pillars, followed by interoperability standards. It can be linked to automation and AI. You obviously have to have the citizen engagement and capacity building with ensuring security. To implement all these, you need some sort of an emerging technologies that need to be supporting the backend. It starts off with artificial intelligence, generative AI, cloud, and the geofencing based technologies, digital twin, IoT sensors and drones. But the base of this information is coming from the satellite data sets, drones, GPS information, field data collections, and it can be served through the internet. Now, if we talk about some challenges in the Northeast region, as we all know that the Northeast region is propelled through various schemes of development. There are schemes like PM Divine Scheme. The Niti Aayog also allocates a certain amount of fund for development of Northeast region. But there are various challenges also. The challenges are the settlement there is fairly scattered. Okay, there's limited connectivity. You have to accessibility of say health facilities, education facilities to the remote areas is also limited, and also there's a lot of frequent disasters that happens, and data is also present in a lot of silos. Now, when you talk about disasters, just to give you a few statistics, Assam Water Resource Department carried out a study, found out 39.5% of the entire state is flood prone, and that accounts to almost 9.4% of the entire country. Then we also had in the past 5 years around 1,000 plus landslides that were reported. 8% of the region is under high landslide hazard zone. Uh, the whole region is under seismic zone 5. There are a lot of frequent earthquakes that keep happening in the region. And during this season now, from the next month onwards, there'll be a huge thunderstorm scenario. Also, there are a lot of frequent lightning strikes that keep happening. And obviously, the region is also prone to forest fires also. So in the past 2004 to 2024, some statistics I took out, around 6.9 lakhs incidents of forest fire occurred in the region. That's a huge number over there. So taking all this thing into our consideration, we developed a spatial data infrastructure platform. It was called as Northeastern Spatial Data Repository. Okay, this platform currently hosts around 1400 plus GIS layers that can be actually used by different government departments. They can download the physical GIS layers, or they can also consume these data set as services. Currently, we have developed customized applications also for around 25 plus government departments, where using this data, customized use case applications have also been served to them. In R&D mode, we are also working on a Geo AI model development that can be effectively utilized to solve critical use case, especially in the case of any user department, also cloud native geospatial workflows. So this is some of the high level architecture when we talk about the implementation of the NESDR platform. We start off with the geospatial products from which are collected from the various GIS layers that are coming from ISRO DOS, State Remote Sensing Application Center, and other government departments. Then the external web services are also being consumed from the Bhuvan web services, Vedas web services, and Mosaic platform. These data sets are being served through a service-oriented architecture in a web container platform, wherein you have the catalog of these GIS layers. We have the spatial engine that can process these data sets, provide geoanalytics applications as web services, translate them into APIs, web applications, or dashboards that are being consumed by the various user departments. Now, coming on to the data availability, as of now, we are close to 1,500 data sets. This is a little old figure, but we are close to around 1500 data set, and this is how it has been distributed across the different states. There have been around, the data set utilization has also been tremendous. We have around 90,000 plus data set that have been downloaded across the user departments in Survey of India grade 50K size. Now, how do you access these data sets? Fairly simple. You have an integrated geo portal. You access the data set through the integrated geo portal. You consume them as a web services, either through some GIS web services, either WMS service. Some data sets we are also providing as WFS, or you can provide a request for download where this data you can access as raw shapefile by submitting a safe custody form. These are some of the data sets that have been uploaded into the platform, where you can see the land use, land cover information is also been provided. Now, this is a new activity that is being carried out. Annually, using deep learning based models, we are generating the land use, land cover information and uploading it to the portal. So if you go now, you'll be able to see the last year's land use, land cover information for the entire region. Then you may be aware of a agriculture practice called as zooming, where what they do is they burn a certain area after cultivation, and mapping this zoom land is a very critical task in the region. So zoom land mapping for the entire northeast region has been carried out and being deployed in this portal. Obviously, road network and high resolution LULC information is also provided. Some of the critical use cases, how the different user departments just downloaded this data, utilized it in their workflows, is being provided in this table. Majority used it to prepare some DPRs, healthcare assessment was being carried out, then also telecom connectivity implementations were also being carried out for the various departments. Now coming on to how we have developed different use case applications and what were the major capabilities that were developed over the years when it comes to WebGIS and free and open source technologies. So the major capabilities that we started off with was, we started off with simple geotagging and monitoring of projects and displaying it in the dashboard. Then we moved ahead. We moved to a geofencing based and location based services capabilities, where some sort of a geofencing based alerts or information can be disseminated to the ground level. WebGIS analysis was obviously one of the key factors. Location tracking is like we all see how we are tracking our food when it comes from Swiggy or Zomato, or we are tracking an Ola or Uber driver. Similarly, a location-based tracking system was also implemented. Advanced raster analysis server was also built, where you could actually process large volumes of satellite data on a cloud-based environment. I took a workshop of that yesterday on how to implement that. And development of ML ops into the overall workflow was implemented. These are some of the use case applications that have been developed, deployed, and being used by the different government departments in the region. Now, fine. So this is one of the first examples that I would like to showcase. Here what we did was we wanted to develop this platform for Ministry of Development of Northeast Region and Northeast Council. They have multiple projects spread across the region of the Northeast, where you can see around 1,500, 1,600 plus project locations are distributed on the this section of the slide here. These projects were being monitored using time series satellite images, geotagged using the mobile applications, and even the roads were getting monitored using the mobile application. We also developed some pilot case studies where you could actually deploy a AI model on a feed that is coming from a dash cam and detect the quality of the road, where how much potholes are happening in the region. And based on that, you can get the density of the pothole information again. And then followed by that, we also developed a 3D based drone data visualization platform, where you do a drone survey for a region, a particular project site, and you visualize it in 3D, and that in that way, you can assess the progress of the project also in a 3D mode. And obviously, once you develop it, you train the people, and this also was launched by then Honorable President of India, Sri Ramnath Kovind. Now, the next one is basically how we have been effectively able to utilize GIS in the field of elections. So elections is basically two-step process. The first one is the planning phase, and the second one is the monitoring phase. So during the planning phase, what we do is we take the data from the election department, we add what GIS layers we have to it, provide value additions, such as we get information about something called as assured minimum facilities, like whether the area has electricity, whether the area has, whether the particular polling station has electricity, adequate furniture, drinkable water, washrooms are there or not. All this information has been mapped for different polling stations across the region. The next thing is what happens is you connect the GIS layers to it. So what is the nearest police stations available to it? What is the nearest health facilities available to it? How is the connectivity to the road? So all these things, based on this, you would develop a planning dashboard to identify the gap areas. Then followed by that, you do something like a monitoring on the poll day. So on poll day, what happens is you start off in the morning. You track the people who start from the base station to their polling station. Once you have tracked them, you also ensure that during the mock polls, the machines are working fine. If the machine is working fine, if there's any fault in the machine, based on the tracking, you also track the sector officers and the flying squads. They are able to dynamically call the sector officers to the place where the machine is actually faulty. You can also see the mobile app reporting was also carried out, where few polling stations, some vandalism was there. So this is how you could actually monitor this, and this platform is being effectively utilized as and when required by various state election departments since 2018 onwards. Another thing that was very recently launched in the last year's November 2025, is a platform called this is written as Axam but pronounced as Akhom. Akhom is how you pronounce Assam Assam is pronounced as Assam. Akhom, okay? So this is an alert aggregator platform. What happens is it aggregates alerts from various agencies such as IMD, CWC, IITM, NESAC, FSI, and provides them as a geofencing based early warning to the users of the mobile application. Additionally, what it does, it also gives you value-added information, such as what are the nearest relief facilities where the alert has been issued, what are the nearest health facilities where the alert has been issued, and on an experimental mode, what we are also doing is, there is someone called as disaster volunteers called as Apada Mitras. Okay, they have been trained by National Disaster Management Authority to provide you some of the basic first aid infrastructure, like first aid related services. So you can connect them to the nearest Apada Mitras using this mobile application. We also did some AI-based LLM models to implement natural language-based queries on the GIS layers, and we implemented RAG agents and implemented them through RAG agents. And this is a very short video that will show you that. Just wanted a very quick query like how many health facilities are there in Assam, so it just populates them with the various health facility locations. We also want to know health facility in Jorhat district. So it zooms into that area. So this is what we were able to implement using open source models, open weights models, and using open source technologies. And this also shows you which are the various locations where the alerts were there and which are the locations where the lightning information was there. So if you see here, if you notice this, you see these polygons? These polygons are actually the lightning alerts that were being generated from the ground stations, and this information is also going at the ground level. Coming on to tourism development, this is something which is, the development part is complete. Now we are planning for the release of this application. As we all know, Northeast is hub for tourism activities. The thing is how to better plan and monitor the tourism related activities. So therein we developed this platform where around 1200 plus tourist locations were mapped with detailed information such as what are the facilities available in that particular tourist location, what is the entry fees, whether parking is there or not, along with various utility point informations also were provided, such as nearest ATMs, health facilities, and so. Then Government of India has also identified around 40 plus tourist circuits that are being taken up for development perspective also. So these tourist circuits were also mapped onto it, and we also developed something called as a tourism potential index, where the potential sites can be taken up for further development of tourism related infrastructure. Mapped few locations for the UAV fly-throughs. So even before visiting the place, any person can visit this portal and see a detailed UAV immersive experience of the particular location, along with some 360-degree photo visualizations for the tourist locations have also been provided. Coming on to what we do for health sector. Now, in case of health sector, we work with Indian Council of Medical Research, ICMR. There are certain regions, certain states in the region which are malaria endemic. Now, in order to combat that, the first thing was you need to identify the malaria hotspots. Also, you need to understand where these regions malaria is happening and why is it happening. So you identify malaria risk map also. So during this process, there are health volunteers called as ASHA workers who work in the ground level. Mobile apps were provided to these ASHA workers, and these mobile apps were so built that they're very easy to use with pictorial representations on, say, a person who has a very basic education background can also utilize this. Using this, around 15,000 plus incidents were reported from the ground. Once you have the incidents that are reported to the ground, we developed a malaria risk map for the entire state of Tripura. We also did something called as mosquito type spatial distribution. So there are different types of mosquitoes that breed in different areas. You wanted to actually identify what is the type of mosquito, how they and which are the locations that are breeding. So an AI model was also developed to automatically classify the different types of mosquitoes. So based on that, the malaria intervention system was developed. Another one is something called as a disease called as African swine fever. African swine fever is basically a livestock disease that usually translates to humans also sometimes. This usually happens in piggery industry, and transboundary, it is a transboundary animal diseases. So it translates from one state to another state while transportation of these livestock. So the transboundary animal disease system was also developed. Couple of more things that were done. One of them was how do you actually identify the connectivity and gap, especially with reference to health and education sectors and telecom and all this. So as we all know, health sectors, all health facilities, education facilities, they have a certain catchment that are associated with it. What we did was we took that information, such as all the health facilities information from an education facility information from PM Gati Shakti platform, and we have the village level point information, and we mapped the nearest health facility from each village. So that was a pretty huge exercise because around 1 lakh schools were there, 35,000 plus villages were there. So 1 lakh cross 35,000 distances were calculated, and minimum of each was calculated and plotted. And then that was translated in dashboard-based environment, and this information was also sent to Niti Aayog's Sambhav program that is called as saturation of model blocks and villages, where they had around 75 plus model gram panchayats that were being monitored under this scheme. One more thing that we are doing now with Manipur Forest Department, that is called as Forest Resource Analysis and Monitoring System, where we have developed something called as an AI-based model to automatically detect deforestation using time series satellite images. The moment you have detected that deforestation is happening, you will be able to send that information to the ground level to the particular district forest officer, and that district forest officer will be able to go there and validate whether the model was correct, model prediction is right or not. Okay. Once, if the model prediction is right, it reinforces the model. If it is wrong, we take it as a feedback and correct the model. 5 more minutes. Yeah, done. 2 slides. So, as we all know, to ensure the sequence of these operations run properly end to end, many trainings have to be also provided, many workshops have to be done. So we continuously carry out multiple workshops across the region, and we train many people through our outreach program also. And for all these activities, we got a few awards also. So the fever tracker application for malaria mapping, we received the most innovative technology year 2022 by ICMR. We received a national award for e-governance for the NESDR platform. Then the project monitoring also received e-Northeast award, and the portal was released by Honorable President. So that's all. Thank you.